Alright, this is the last video that I'm going to be doing for you guys. I just need to find where the pen is so I can write on the computer. We're going to do number 29 here. Number 29 says to find the final price of a shirt after applying discount and tax. There you go. And what we can do here is we can go and take $28. First, let's go and change this to a percent. To a decimal. 20% is 0.20. 6.5% is 0.065. And in order to find the price, what I'm going to go and do is take $28, multiply it times 0.2. I believe I get $5.60. You can check it on your calculator. And then because this is a discount, that's how much I get to save on the shirt. So what I need to do is take $28 and subtract $5.60. And I believe that's going to get me $22.40. And again, the only reason I know that is because I got my calculator. So next, I took care of the discount of 20%. I got to add tax onto that though. So I'm going to do $22.40 times 0.065. And I have no idea what that is, so I got to calculate that. And that looks like it's going to be $1.46, but let me double check. Times 0.065. Yep, $1.46. It's really $4.56, but you should round to the penny. So $1.46. And again, that's how much tax I'm going to be paying on this shirt. So to get the total, I need to take $22.40 and add on a $1.46, and I end up getting $23.86, and that is the cost of this shirt with the 20% discount and a 6.5% tax. Here's the next video, or next problem, number 30. X plus y equals 3. Now I saw a lot of my students actually going ahead and just ignoring the fact that this is standard form and just going right to slope-intercept form, which is totally fine. The way I got negative x plus 3 is I subtracted x on both sides, and we had a positive 3 here. So this is negative x plus 3. To graph that, I got to go up 1, 2, 3. That's my first point. A negative slope, so when m is negative 1, it's really equal to a negative 1 over 1. I'm going down 1 and to the right 1. So down 1 to the right 1, down 1 to the right 1. And I'm going to use my straight edge and make sure I make a nice clean line. Let's go ahead and just use black. And perfect. And again, what I'm doing is I'm looking for a point of intersection for these two lines. So I'm going to go ahead and graph the other one. We'll do this one in purple. And let's see, I can go ahead and add an x to both sides. And I get 3y equals x minus 3. Divide by 3 on both sides. And I get y is equal to, again I divided by 3 because I was multiplying, 1 over 3x minus 1. Here, the m is telling me it's a positive 1 over 3. So I got to go up 1 and then over 3. Okay, so let's graph the y-intercept. The y-intercept is negative 1. There's negative 1. I got to go up 1 over 3, so I end up right here. And how convenient. It looks like I'm going to get a nice little line here. Very excited. So let's go ahead and get the line. And again, if I'm drawing it correctly, I get a nice big intersection point, which is exactly what I want, and it's in green here. And they intersect at 3, 0. X comes first, so the point of intersection is 3, 0. And let me move my face here. And how many solutions does the system have? The system has one solution. There is only one intersection point, so one solution. Number 31. Okay, here we got to use substitution. It looks like y is already solved for, so I can go and take this entire part and plug it into y. So I'm going to get 8x minus 4 times, and then in big parentheses, I'm literally plugging in negative 5 halves x plus 3. Because this is y. And it's equal to 6. And again, I just want to make sure we're clear, this was y from the top equation. And then I'm going to simplify this. I get 8x. I'm going to use my calculator here. Using the calculator. And I'm going to get a plus 10x. I'm going to get minus 12 equals 6. This part is equal to 18x when I combine like terms. When I add 12 to both sides, I get equals 18. Then when I divide by 18 on both sides, I'm going to go in and get x is equal to 1. Okay, if x is equal to 1, I got to solve for y. And here is a perfect equation to solve for y. The reason I could solve for y there is because y is already solved for. I could plug 1 into this equation, but it's going to be a little bit more work than I need to do. I'm going to plug y into the top x into the top equation, so y is equal to negative 5 halves times 1 plus 3. Again, 1 is x from what we got down here. And then that means that what I get is negative 5 over 2 plus 3. Oh, but we got to do our fractions though. So let's keep going. Negative 5 over 2 plus, I believe this is 3 over 1. And I'll multiply by 2, top and bottom. And I get negative 5 over 2 plus 6 over 2, which is equal to 1 over 2. And again, please use your calculator for negative 5 plus 6 to make sure you get a positive 1. And our answer, finally, is going to be x comes first, so it's going to be that value of 1, comma, 1/2. And there's your answer for the system. And remember, the way you could check your answer is you could plug in 1 back into the problem and you should get a half. You could plug 1 and a half into the bottom equation and you should end up getting out 6. Next problem, 32. Well, thankfully, I'm almost done. I only got 10 more problems to explain to you guys. So, what I told my class for number 3 for elimination is I'm looking for signs to be opposite, numbers to be the same. Here, for the x's, my signs are the same, so I don't really want to try to cancel x's out. I'm going to try to cancel y's out because the signs are opposite, but the numbers in front, the coefficients, are not the same. So I need to make them the same. I'm going to multiply both sides of the top equation by 3 because I anticipate getting a negative 12y. So the bottom equation, I need a positive 12. So what I'm going to do here is I'm going to multiply by 4 to get a positive 12. Both sides of the equation, of course. The top equation is going to become negative 6x, and make sure you're distributing, minus 12y equals negative 2 times 3 is negative 6. For the bottom equation, I get a negative 12x. 4 times a positive 3y is a positive 12y. And I'm going to equal 15 times 4, and that's 60. Please, 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 please make sure that you are multiplying that last part also if you're changing either of the equations. Because some students I'm seeing are putting 15 and negative 2. They forget to multiply the other side of the equation by whatever number they're multiplying. Okay, we're going to go and eliminate those two variables because negative 12y and positive 12y cancel. And I end up getting negative 12x minus 6x equals negative 6. Since there's no sign here, so automatically a plus 60. And then I end up getting here, using a calculator, negative 18x. Using a calculator, I end up getting 54. Divide by negative 18, because negative 18 is multiplying x. I get x equals negative 3. And, okay. Sorry, I was thinking about something else here. And I have to plug negative 3 back into one of these equations, so I'll choose the top one just because it doesn't matter. I'm going to do negative 2 times negative 3. When I put the number in parentheses, I'm multiplying it. Minus 4y, because that's what I want to solve for, equals negative 2. Negative 2 times negative 3 is a 6, minus 4y equals negative 2. And when I solve for y here, I'm going to subtract 6 and subtract 6. I get negative 4y is equal to negative 2 minus 6 is negative 8. Divide by negative 4, divide by negative 4. Y is equal to 2. So my final answer is negative 3, 2. Oh, it's back on. Okay, so 33. Okay, I can use any method I want. I want to use elimination for this one because I see a positive 2x and a negative 4x, which means all I need to do is make this 2x and 4x to cancel them. So I'm going to multiply the top equation by 2, both sides of the equation. I'm going to rewrite everything. So I end up getting 4x, because 2 times 2x, plus 2 times 7y is 14y, equals 46. The bottom equation will be negative 4x minus 14y equals negative 10. Let's see what we have here. Oh my gosh! Look at this. Cancels, cancels. I get 0 equals 36. False. That could not be more false. There is no solution here, which means graphically the lines are parallel. Ah, I love when things do that. I love when it just works like that. It's amazing. Okay, number 34. 3x plus 7y equals 3. 12x plus 28y equals 12. It doesn't really look like I could actually solve for anything here. That looks like it would be easy. So I'm going to go ahead and just multiply this by 4 to eliminate the 12s. But notice they're both positive, so I need to make the top one negative then. So I'm going to multiply everything by negative 4. And I get negative 12x. I'm going to multiply negative 4 times 7y to get minus 28y equals, and we're going to go to negative 4 times 3, that's a negative 12. The bottom equation didn't change. And when I add everything up, holy moly guacamole, Batman, I get 0, a 0, and that's a 0. I get 0 equals 0. Hey, that's a true statement. True. All real numbers. And if you want, you can go in and put the double R. There's your answer. So that means that this has infinitely many solutions. Infinitely many solutions. And actually, I'm going to change something here. And I would say, I would rather you write infinitely many solutions. I don't want you to write all real solutions, because that would be for something else. Infinitely many solutions is what we're looking for the system of equations. Okay, we're almost there, guys. 35. Let's graph. Y is greater than or equal to 2x plus 1. And y is greater than or equal to 2x plus 1 is going to be graphing. I got to go up 1. And then I got to go, my slope is 2. So when the slope is 2, I got to go up 2 and then over 1. So up 2 over 1. Here are my 2 points. Now, I've got a solid line because I got a little greater than or and equal to. So what I'm going to do is choose a solid line here. Let's make this a red line too to match our points. And, oh no, that's embarrassing. Let's try it again. Alright, perfect. Alright, I could do a little bit better. Again, I gotta be really particular about when I graph these to make sure that I'm getting the right picture that I need. Okay, that looks pretty good. That looks even better. Alright, so now I got a shade. So what I'm going to do here is shade. I'm going to choose 0, 0 as a test point. And let's see, if I plug in 0, and that's greater than or equal to 2 times 0 plus 1, I end up getting 0 is greater than or equal to 1. Okay, that's false. So because 0 is not greater than or equal to 1, I am not shading in the 0 direction, which means I'm going to shade in the opposite direction. So I'll use some blue here. I'm going to shade all of this stuff. All of this stuff. Mr. Goldstein is leaving for the day. I'm unfortunately the last one here. But hey, I'm almost done though. I'll be able to get out of here if I can ever finish coloring this. Alrighty. Okay, next one. Let's go and do purple. Purple, here we come. Oh, not the calligraphy pen. There we are. X plus 3y is greater than 6. We can go ahead and move everything over to one side. So we get 3y is greater than negative x plus 6. Divide by 3, everything. And I get y is greater than negative 1/3 x plus 2. Notice, 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 notice. This is a dashed line. Let's try that again. Again, dashed line. So, let's go and get a purple line here. And let's get a dashed line. So a dashed purple line. And let's see here. Let's try that again. Okay, perfect. And I got to go, oh, I didn't even plot the points. Oh my gosh. I got to plot the points first. I got to go up 2, which is right there. I got to go, my slope is negative 1/3, which means I got to go down 1 and 3 to the right. So down 1, 3 to the right. And again, I am making a line that's supposed to be dashed. Oh my goodness, Mr. Lakin, what are you doing? Okay, let's try that again. So a dashed line, there we go. I'm drawing a line through my head right now. And okay, now let's see how to shade this. So to shade, again, I'm looking at 0, 0. So let's look here at 0, 0. And let's set 0, 0 in this equation. Is 0 greater than or equal to negative 1/3? I'm sorry, is 0 greater than negative 1/3 times 0 plus 2? That simplifies to 0 greater than 2. False again, which means we need to shade away from 0, and I'll shade in purple this time. Here is the purple. Ooh, this looks fancy. And everywhere that the color is changing is the answer. Now I have to color all this in because my 7th period class doesn't like if I leave out any part that's not colored. They get very angry about that. So, there you go. That blue part is your answer. And when I say blue, it's this dark blue part is your answer. Let's keep going. 36. We are almost there, guys. I am very excited because I'm finally done. Mr. Foster's in an airplane that is 5,280 feet above sea level. He starts feeling the plane decreasing at an altitude, decreasing altitude at a rate of 120 feet per minute. That is a slope. And because we have decreasing, m equals negative 120. Also, I notice that it's 5,280 feet above sea level, which means that that's my starting point, my y-intercept. So to write an equation of a line in slope-intercept form, what I'm going to do is use these two values. Y is equal to negative 120 x Let's do t because we're talking about time. X would be fine, but t is a little bit better because we're talking about time. So negative 120t plus 5,280. And we'll say that, again, per minute, we'll say we have t here. Now the standard form is when you have x's and y's on one side of the equation and numbers on the other side. Here, my y's and my t's are not on one side of the equation. I need them on one side of the equation. So what I'm going to do is I'm going to go ahead and add 120t to both sides. And I end up getting out 120t plus y equals 5,280. That's in standard form. Okay, for the last part, we need to explain the significance of the x and y intercepts. So first of all, the y-intercept is 5,280. What I can get that by actually rewriting this twice, first of all. So to get the x and y intercepts, that's that hide trick. And I'm not sure Miss Locus's class is what she called it, but basically it's where we hide a variable. Let's go do this again. So that means y is 0. When we hide the variable, y is 0. And when I do 120, when I solve for t, I'm going to divide by 5,280, which is, let's see what that is equal to, 44. Okay, very nice number. Again, I got 44 by dividing 120, because I'm let t equals 0. So I just have this one equation. I get t equals 44. For the other equation, I would solve for y, and again, that means that t is equal to 0. So t equals 0, y is equal to 5,280. And this first part is my y-intercept, or t-intercept. My second, this part on the left is going to be my x-intercept. And rather, this would be your t-intercept. That would be your y-intercept. Either way, here's the significance. In red, at t equals 44 minutes, Mr. Foster lands. At the beginning, for the green, at t equals 0 minutes, Mr. Foster is 5,280 feet above sea level. These were kind of tougher problems because you actually had to solve for the x and the y-intercept to get the equation. I don't think it's going to be that complicated on the test. Please talk to your teacher if you're worried about this problem so you can get another practice problem. All right, 38. Oh, 38. Love 38. Because all you need to do is the following. 3 times. When you plug a number in, put it in parentheses. Plug number in, put it in parentheses, which means I get 3 times negative 4 squared plus, minus, oh man, 2 times negative 4 plus 1. Okay, let's do some order of ops here. So I need negative 4 squared. Well, because the negative is inside the parentheses and being squared, I get a positive 16 out. So 3 times 16. A negative 2 times a negative 4 is going to be a positive 8 plus 1. And I get 48 plus 8 plus 1, which I believe is 57. Next. Number 39. Okay, translate this statement. So here's what we do. 5 less than 3 times the number. I'm going to start here, actually. 3 times the number is 3x. And 5 less than that number goes here. This is 5 less than 3 times the number. Is equals 4 more than, I'm going to skip that, 6 times the sum of a number and 9. Oh my gosh. Okay, so the sum of a number and 9 is going to be x plus 9. Again, a number is x, the sum is plus, 6 was times, and then we have to deal with this 4 more than, so 4 more than is going to go at the end. So the actual problem is 3x minus 5, or the solution, is 6x parentheses x plus 9 plus 4. Okay, 40. This one's going to be an inequality. It has half a number, so we'll have to do half. A number will be x is greater than or equal to. So greater than or equal to will be that part. 3 times the same number, so 3 times x, increased, that means add, by 4. So just rewriting this, we have 1/2 x is greater than or equal to 3x plus 4. And then for the final problem, and this is finally it, 41. Find the line of best fit. So this might be tough to do because we're going to be really approximating here. And it looks like I could choose about, oh my gosh, these are horrible points. Let's do 14 and 225 I'll choose. So 14 and $225 I'm going to choose. And I'm also going to choose, it looks like this is 20, comma, oh man, it looks like about $450. Again, answers are going to definitely vary here depending on what points you picked. So to find the line of best fit, we would have to do slope first, y2 minus y1 over x2 minus x1, which is equal to, again, 450 minus 225 over 20 minus 14. And if you're not sure how, I let this one be y2 and x2, and I let this one be y1 and x1. And when I do that math, I end up getting 450 minus 225, I think is 225. And 20 minus 14 is 6. And 225 over 6 is going to be 37.5. And then to get the equation, I just need one other point. So I'll choose the first one that I saw, which was 14,225. And when I use that, 225, when I use that, I get y minus, again, y1, 225 is equal to, I need my slope, 37.5, oh no, 37.5, parentheses, x1, x minus 14. Again, this value was x1, this value was y1, and the answer is going to totally differ here. So please be aware that I used 14,225 and 2450. And there's my answer. And other than that, guys, I hope I did okay on explaining everything. Thanks for taking time to watch any of the videos. And other than that, good luck on your tests. Thanks.